8.7 is on inverse operations, and we're going to be calculating the value of an angle using inverse functions. So we're going to use the trig ratios to find side lengths, and we're also going to set up our inverse operations the same way using our SOHCAHTOA. So knowing that is going to be helpful in this section as well. And then our inverse ratios, we are going to be doing the opposite of them. So for example, we know that sine of an angle is equal to the opposite over the hypotenuse. If we needed to figure out what angle A is, we're going to do the inverse of sine, and that's sine to the -1. So by doing that, the sine -1 and sine, those are inverses, so they undo each other, or they're inverse operations, like adding and subtracting. That would leave us with just angle A would be equal to the inverse sine of the opposite over the hypotenuse. And the same thing works for our other two functions. So for cosine, that is equal to our adjacent over hypotenuse. So if we were to do the inverse of cosine, we would do cosine to the -1, which we would pronounce as inverse cosine. And then the cosine and inverse cosine would simplify, and we would be left with angle A equals the inverse cosine of A over H. And again, that works for tangent as well, where we have our opposite over adjacent. And we would take this and we would multiply by our inverse tan on both sides. So they simplify, and we're left with angle A equals the inverse tan of opposite over adjacent. So that's how we're going to use SOHCAHTOA to also go ahead and find our angle measurements in a triangle. Example 1, we're going to use a calculator to approximate the measure of angle A to 4 decimal points. We're going to start this the same way we started our last problems. We are going to label the triangle with our opposite, hypotenuse, and our adjacent. And then step 2, you're going to choose one from your SOHCAHTOA that you're going to use. And the way we choose is we look at which side lengths they give us. And this one, they give us our opposite and our adjacent. So we're going to be using tangent. Step 3, you're going to write equation. So for this one, we said we were going to use tangent of angle A because we don't know what that angle equals yet. And that's going to be equal to 16 over 20. And our next step is to solve for our variable again. So this one, to get angle A, this is when we will take our inverse. And we only do this when we're looking for an angle measurement, not a side length. So when we do that, the inverses simplify with each other, and we're left with angle A equals the inverse tangent of 16 over 20. This is where you can type it into your calculator. On most calculators, you're just going to hit the second button and then the tangent key, and that will give you your angle measurement. So for this one, I'm going to go to my function for my inverse tangent, and we'll type 16 divided by 20. And they told us to round to 4 decimal places, so we're going to have 38.6598. And because this is an angle, we're going to label it with degrees. So the steps are very similar to those that we used to find a missing side length. We're just going to be using different functions like the inverse here. Now if we look at example 2, we're going to use a calculator to approximate the measure of angle A and angle B to 4 decimal points. So for this, they just gave us an equation. They didn't give us a triangle. And that's okay because we're still going to solve it the same way we did before by using our inverse functions. And you're always going to do the inverse of whatever function they give you. So this one, they gave us sine of A, so we're going to use the inverse of sine to figure out what angle A equals. And when we do that, we're going to get A is about equal to 49.4642 degrees. Then we'll go ahead and do the same thing for cosine of B, which equals 0.17. We're going to use the inverse function of cosine. So those simplify with each other, and we are left to figure out what angle B equals. And most of this you will do on a calculator, but make sure you show your work so that if you accidentally type in a number wrong, you can still get partial credit for knowing how to do the equation part. Okay, so we just have a few more examples to go through. Our next example 3, we're going to solve the right triangle. And when it says solve the right triangle, it means find all missing side lengths and all missing angles. And we're going to round our answers to 4 decimal points. So looking at this one, we need to figure out the measure of angle B. We also need to figure out the length of AC, which in triangles like this, they usually represent the side lengths as the lowercase letter of the angle opposite of it. So this one would be a lowercase a. So for this problem, we are looking for 3 pieces of information. In this one, we were given 2 angles. So right away, we can figure out that third angle by adding 23 and 90 together and then subtracting that from 180. So we know the measure of angle B is going to be 67 degrees. Now we need to find our missing side lengths. So I'm going to solve in order. So I'm going to find A first. And you always want to highlight one that we're looking for and one that you know the side of. So looking from angle A, we know this is our opposite, hypotenuse, and our adjacent. So we highlighted our opposite and hypotenuse. Looking from our SOHCAHTOA, that is going to be our sine function. So writing that out, we're going to do the sine of 23 degrees equals A over 40. And the reason we use 23 is because that's the angle that we labeled our triangle from. So that's why we would put 23 degrees in there. So to solve this, I'm going to multiply both sides by 40 and then type it into my calculator. And when you do that, you would get 15.6292, which is about equal to A. Now we can go ahead and solve for B, which is our adjacent side and our hypotenuse. So this time we're again going to use cosine. So we have cosine of 23 degrees equals B over 40. So then to solve this, you're going to multiply both sides by 40 to get cosine by itself. Then you can type it into your calculator, and you would get 36.8202 is about equal to B. So this one had 3 answers, and there will be a problem like this on the test where you do have to solve a right triangle. So I'm just going to give you a second to make sure you have that all copied down. And then why don't you try number 4 on your own, and then once you have your answer, press play to see if you got it correct. Okay. So for number 4, this one we're looking for an angle. So it says you are building a track for a model train. You want the track to incline from the first level to the second level 4 inches higher in a length of 96 inches. So they've already labeled our picture for us. They want us to find the angle of elevation. So to start off with, let's go ahead and label our sides of the triangle. And then we're going to choose which one of our functions we're going to use from SOHCAHTOA. So looking at this, we do have our opposite and our adjacent. So that is going to be our tangent function. So when we write this out, we're going to do tangent of x equals 4 over 96. And we need to get rid of the tangent, so we're going to do the inverse function on both sides. Those tangents will simplify. So then we would get x equals tan negative 1 of 4 over 96. So let's type that into our calculator. And we would get about 2.3859 degrees. And that would be our answer. Next, we have a right triangle that has a 50-degree angle and a 15-inch, that has an extra E, hypotenuse. They want us to solve the right triangle. So this one, they have a 50-degree angle. Because it's a right triangle, you can put that 50-degree angle in either of the empty angles that you have. So we can put 50 degrees here, or you could put it on top. And then we also know we have a 15-inch hypotenuse. So for that, we can start by labeling our missing sides that we need to find. Because we weren't given any names, you can decide what you would like to label each of the sides and the angles. And we need to solve for all of the missing parts. So for this, we need to figure out the measure of angle A. We need to find the side length of A and the side length of B. And let's go ahead and solve. So we know we have a 90-degree angle and a 50-degree angle. We can add those two together to get 140, and then subtract that from 180 to find our missing angle, which would be 40 degrees. Then we need to go ahead and solve for A and B. I'm going to go ahead and solve for A first here. And if I label my triangle from point B, we would have our opposite, adjacent, and our hypotenuse. So setting up our equation from that information, looking from our SOHCAHTOA, adjacent and hypotenuse is going to be cosine. So we can do the cosine of 50 degrees equals A over 15. Go ahead and multiply both sides by 15, and then we can type that into our calculator. And we would get that A is about 9.6418. And now we can go ahead and solve for side B. So side B is our opposite, and I'm still going to use that hypotenuse because I know that length is exact values. So because we're using opposite and hypotenuse, we're going to be using sine again. So we'll do sine of 50 degrees equals B over 15. So to solve this one again, we're going to multiply both sides by 15 and type that into our calculators. So for this one, we should have got 11.4907 for our B value. So this one, we had 3 answers that we needed to get. If you have any questions on this lesson, just let me know and I'll get back to you as soon as possible.